In this video, I want to present 5 approaches for quantitatively assessing price sensitivity. We'll overview 5 approaches for quantitatively assessing price sensitivity. A commonly applied summary measure for price sensitivity is price elasticity, measured as the percent change in sales over the percent change in price. In its most basic form, it is relatively easy to compute, using 2 values of price and the associated sales at each price level. Compute the percent change in sales over the percent change in price. Observe that a price elasticity is unitless, which makes comparisons easy. Method number 1. You have little time or resources to do something on your own. In this case, leverage publicly available studies and adjust their findings as best you can to your product and context. Sometimes you may get lucky and a search in Google Scholar returns a study that closely aligns with your product and context. More likely, you rely on something called a meta-analysis as a starting point. This is a scientific method to summarize the results from a large number of quantitative studies. It is commonly used in the health sciences, but every 15 years or so, someone publishes a meta-analysis for price elasticity. This slide shows a few page grabs from one of these studies. The center panel shows the frequency distribution of the almost 2,000 price elasticities the authors studied. It is slightly right skewed, with the mode being around -2. The right panel highlights that variation in the price elasticity of different products can be due to factors that include the product category and stage of the product life cycle. The meta-analysis found that the median price elasticity was about -2.2. This informs your starting point, which will be say -1.5 to account for publication bias. Then you add and subtract from -1.5 using the offsets published in the paper that describe your product and context. Method number 2. You have historical data on your sales and on variables that describe the marketing effort to generate those sales, including price. There are 2 approaches. The first is to use 2 prices and their corresponding sales to calculate an arc elasticity. The second is when you have multiple data points with price and their corresponding sales. Regressing log of sales on variables that describe the marketing effort returns a coefficient of price that, when multiplied by the average price, is a summary measure of the price elasticity. The easiest way to get a summary measure of price elasticity is to regress log sales on log price while controlling for other factors that affect sales. The coefficient of log price is the price elasticity. As an example, consider Kingsford Charcoal. The data are annual, so there are no concerns with seasonality. The dependent variable is sales volume. We seek to explain the variation in sales volume with variables describing 3 elements of the marketing mix: media spend, trade promotion spend, and consumer sales promotion spend. Of course, with only 5 data points, we will use caution in interpreting the results. We take the log of all 4 variables in order to estimate a log-log regression model. The coefficients of a log-log regression model are read as the elasticities. Of the 3 marketing mix variables, trade promotion expenditures has by far the largest elasticity. This makes sense considering the category. Outside of the major holidays, outdoor barbecues may be more likely, driven by good weather and the trigger of passing by an in-store display when shopping. Method number 3, experiments. Field experiments. An experiment is a procedure carried out under controlled conditions in order to discover an unknown effect or test a hypothesis. Field refers to doing the experiment in a real marketplace versus, say, a survey. In this stylized example of cell phones, the firm sells its most popular product for $1,200. It could be dollars or euros, and it has about 25% market share. It divides the country up into 3 regions and randomly assigns 3 prices, to each region. $1,200, the current price; $900, a 25% price cut; and $600, a 50% price cut. After 3 months, we have the market share for each region. This is plotted here. Straight away, we see the slope is very shallow, going from 600 to 900. What does this mean? Well, if we were going to charge 600, we might as well charge 900, as there is very little drop-off in demand for the price increase. However, going from 900 to 1,200, we see a big drop in demand. We don't know the margin the product earns, so we can't make a definitive recommendation, but it is certainly worth investigating if it is best to charge the higher price. Field experiments are costly in terms of time and resources. Sometimes we can run an experiment by randomly assigning subjects to different conditions. In this stylized example, each subject in an online survey is asked to select from a simulated shelf set containing 3 products. Each respondent is randomly assigned to one of the 2 prices for your product. Method number 4, a survey of willingness to pay. Assume you are, say, the Atlanta United professional soccer team wanting to price 200 level single game tickets. You ask a willingness to pay question in a survey. While it can be an open-ended question, it is much easier for respondents if you provide response categories, and it is much easier if the response categories are equally spaced. The survey results are the percentage of respondents' self-explicated willingness to pay for each price level in the survey. We recast these results as the cumulative demand at each price level. For example, for a price of $90, the demand is the 27% who selected $90 plus those who would pay higher prices, i.e. the 22 who would pay $105 in this case. For each price, calculate the weighted revenue as the cumulative demand times the price. Look for the maximum. In this example, the maximum is when price is $75, so the optimal price is $75. The same data can be used to calculate arc elasticities at each subsequent pairs of prices. These are plotted here. You can see that the curve is relatively flat for prices below $75. So if you're going to charge $60, you might as well charge $75. After $75, the slope drops off considerably, so $75 is roughly the price to charge. Method number 5, conjoint or trade-off analysis. Conjoint analysis has been covered in other videos. The idea is to present respondents with a series of products defined by their attributes and ask them to rate or choose products. The data shown here are from a stylized example of a large meeting video conferencing platform. Conjoint analysis provides the utility for each attribute level. Shown here is the price. As would be expected, as price increases, all else equal, utility declines. By relating utility to demand, we can use these results to calculate a price elasticity. In summary, we have examined 5 different approaches to quantitatively assess price sensitivity, 2 that use secondary data and 3 that use primary data. This concludes this video.